Cool.
Hello, and welcome to our second day of the Virtual World's Best Practices in Education Conference. We've had an exciting morning at Cloud Party, and we are back in Second Life for another round of fabulous presentations and an excellent machinima feature. Our next keynote will likely say that she is just a physics professor. However, she is much more than that. She is an associate professor in the Department of Science and Mathematics at the National Technical Institute for the Deaf, and her work there spans 35 years. Her work in Second Life brings physics experiments into an engaging learning experience. Vicki, however, is the best person to talk about this. Please help me welcome Vicki Robinson, best known in Second Life as our Professor Snoodle. Vicki, the floor is yours.
Thank you, Letty. Okay, as Letty said, my name is Vicki Robinson, Odd Professor Snoodle in Second Life, and I teach physics in real life. I use Second Life to support my students' learning. Well, I'd like to talk a bit about my students, the reasons that I'm so enthusiastic about this kind of interactive learning, and how I'm doing it. So, let's get started. The sage on the stage. Much of higher education is marked by the dynamic of the sage on the stage. We talk a lot about the flipped classroom and the guide on the side, elements of distance learning that have been worked into traditional classrooms to varying degrees of success. Nevertheless, all students have stories about the professor who droned away in a monotone in an overheated classroom, or the professor who was lively and interactive and didn't give anybody a chance to nod off. The pedagogy of both of these examples, however, is teacher-centered, and that's how many of us were taught when we were on that side of the desk. It puts little responsibility for the construction of knowledge onto the students' shoulders. I bear most of it, but that makes sense because I'm the expert, right? No, not right. Knowledge that isn't self-constructed isn't retained. It isn't really knowledge at all, except at the lowest level of Bloom's taxonomy. Now, I need to say a few words about my students before I go on. I teach physics in a technical college for deaf and hard of hearing students. I deal with a very wide range of preparation and ability. There are unique aspects in educating people who are deaf, many of them connected to communication preferences. In my classroom, I use American Sign Language, spoken English, and signed English. Some of my students are profoundly deaf, with a capital D. Others are hard of hearing and may depend almost entirely on speech and speech reading. Many of my students have cochlear implants. Many students consider themselves to be members of a linguistic community that carries many of the markers of ethnicity: language, art, customs, literature, humor, and all of these factors must be negotiated and accommodated. The pace of presentation, the language used between the teacher and the class and among the class members themselves. Environmental influences like lighting, visual clutter, and ambient noise, all those things have to be considered. Also, many of my students read and write at about a 4th grade level due to the difficulty in language acquisition that accompanies congenital deafness. And all of this means that much of the language used in a classroom passes many students by. Even looking down to make a note means that they're missing some content. These factors virtually force, quote, a change in the relationship between the stage and the audience, unquote. The need to respect and utilize the full diversity of communication styles, as well as other factors that aren't exclusive to the deaf community, like race and gender, identity, socioeconomic background, that requires innovation to find engaging ways to give students the tools to create knowledge for themselves. So, slouching towards Second Life. Word problems in physics are never popular with deaf or hearing classes, and given the difficulties that deaf people often have in reading English, the effort for them is compounded. Actually, I've been told outright by a student, "Oh, I don't read, you have to tell me." Well, who can blame them? This is a typical physics problem presented in a typical way. An object accelerates from rest from x sub I equals 0 meters in a negative direction for some time. At the end of delta t seconds, the object's position is at x sub f equals minus 4.86 meters. Now, sketch the position versus time graph for this motion. I'll give you a second to take in the full horror of that problem. The way it's written even makes my head hurt. Now, imagine that simply decoding that question is daunting to you. Never mind understanding what it all means. Well, how do you feel about your task? Well, in my years as a physics teacher, I've tried to make my presentations to my students as visually appealing as possible. It's not just good practice, it's a genuine necessity for my students. Over the years, I've progressed through hand-drawn charts and graphs and illustrations to static diagrams produced by drawing programs to little QuickTime movies created with a 2D modeling program. So, which problem do you yourself think would make most sense to you? The one in this slide that you're looking at right now, or ta-da! Now, you have to imagine that that little red ball is moving to the left, going faster as time goes on. I wanted to make little movies for you here, but boy, I ran into technical problems, so it's all still images. I'm sorry about that. But I have literally hundreds of these little short movies, and they work. My students have told me over the years that the movies in their homework and exams have really help them understand the problems better and figure out how to solve them. But oh man, I wished I could make those little movies real. And now I can. Look at this. There's no comparison. Now, let's take a walk into the past. It is test day. I have constructed what I think is a pretty good test. I've drawn questions from a number of sources, including the lab activities. Of course, we all know that labs are designed to relate to and support the topic that students are studying, and to help the homework make sense. It's the old teach a man to fish story. Labs let the students fish, and it makes their studies real. That was the plan, anyway. Let me read this for you. Look at the table below. It shows the position of a moving object at various times. This is similar to the data you took in lab number 2. Let me repeat. This is similar to the data you took in lab number 2. You see that? Lab number 2. Well, a very disgruntled student accused me of gross unfairness. How was he supposed to know that the labs were included in the test? Well, after asking some probing questions, it became clear that this student felt that homework was his primary learning experience. Labs were things to do, write up, and forget. But remember how I said that labs were meant to help the homework make sense? Something was breaking down for this young man. He interpreted labs as elaborate hoops to jump through to get a grade. It didn't seem to click that his homework and his labs were focused on the same things. I was appalled. So I started asking around in my classes. Well, most of my students understood that lab activities and the topic of study were supposed to be mutually supportive. I mean, thank goodness. But a significant number weren't sure how to bridge the gap between them. A popular problem-solving strategy was to comb through problems for numbers and then try to plug the numbers into random formulas in a way that yielded the right answer. This isn't a sophisticated strategy. But many of my students are naive problem solvers. They didn't have a framework for critical assessment. They weren't sure what they were doing. Except that physics looked an awful lot like math, and they knew how to approach math, so they were bringing the same skills to bear. Plug in the numbers, get an answer, and move on. And I know all of you math teachers out there are going, ah! So, what to do? Telling them wasn't going to work. I guess I just have to bring the lab to the homework. So how can they do labs at 3 a.m. in their dorm rooms? You can't do this in the dorm. Well, in 2008, RIT established an island in Second Life. Well, having read Snow Crash, I was immediately enthralled by the possibilities. I was granted a little plot of land and met with a student who would do the building and scripting for the activity I wanted. I showed her the lab equipment that I wanted her to duplicate, except I wanted it really big. She built it, we played with it, we tweaked it until I got what I thought I wanted, and I invited my students in. Oh dear, it was a disaster from start to finish. Sorting through the wreckage, I realized a few things that in my enthusiasm I had disregarded. Can you see that slide? I can't. Ooh, there it goes. First, I had to spend a lot more time inward building my own skills so that I could teach my students some basic Second Life moves. Second, I had wildly overestimated the students' familiarity with virtual worlds. I had naively subscribed to the stereotype that all of the young'uns played video games. Wrong. Third, I needed to be much more clear about why we were in Second Life and what I hoped they would get from the experience. Fourth, they needed very specific instructions for the activities, at least at first. And fifth, I needed a critical mass of activities. One activity can just be blown off. Nobody has to take it seriously. Well, an entire suite of activities, though, that's something you can get your teeth into. So now, I spend an hour on the first day of class guiding my students through creating an avatar, opening viewer software, finding my science center, walking, flying, changing clothes. We discuss etiquette, the no pushing, bumping rules. I show them where to download the viewer for their own computers. And I also ask them for their usernames and passwords too. A lot of them forget to write them down, and then they look at me blankly when I say, all right, go into Second Life. Okay, so come on, let's get to the good stuff. Blah, 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 blah. So how does this work? Well, we have lab activities ranging from extremely basic, calculating areas of two-dimensional shapes, volumes of various regular three-dimensional objects, to some fairly sophisticated. We do rotation of rigid bodies, angular acceleration. All of the activities are in the realms of mechanics, statics, fluid statics, and I'm doing a little research and development on thermodynamics too. So how do we use Second Life? My students do labs in class. Real life labs, there's no substitute. Then for homework, they do them again in the Science Center to reinforce the concepts. I have created web-assigned homework assignments specifically for each activity. Is everybody familiar with WebAssign? It's an online homework and testing service that I have the students subscribe to at the beginning of the semester. So they open their assignment in WebAssign. Here is a very simple assignment, but it is one that I assign. The students have to calculate the speed of a glider moving between two photo gates on an air track, using the separation of the gates and the time it takes to traverse them. In our lab, these air tracks are about 6 feet long, about 2 meters long. And that's what they look like. The students use this equipment in the lab to solve these problems. But in Second Life, we do things a little differently. Now, you called that an air track. This is an air track. What I've tried to do is duplicate my students' real-life experiences. Remember, they've already done the labs. This is offered as homework to help them think about their labs in a constructive way. After all, we wouldn't give just one problem to practice a concept. Perhaps one lab isn't sufficient either. Okay, remember these students? These students are performing an experiment on volume displacement. They measure the volume of the colored water in their graduated cylinders. They drop an object into the water and record how much the water rises. This is Archimedes' principle. Well, it's part of Archimedes' principle, and it's taught in every physics class in the universe. I'm sure of that. This concept, though, is hard for some students to understand. So they do this lab, and then for homework, virtual volume displacement. What you're looking at is a 9-meter, 29-foot tank holding a 7-meter depth of improbably colored water. Suspended over the tank is a giant granite ball. Students drop the ball into the water. The water itself announces its new depth. And that's what it looks like after they drop it. Can you see down there in the lower left corner? That's the water talking to them. The student who is manipulating the lab gets an IM. So there's not a lot of crosstalk if several students are working at once. Well, this is undoubtedly fun. And it's doubly fun since we figured out a way to res a whole lot of giant granite spheres and make them fall off the platform, 350 meters up. But the thing I like best about it, my students can repeat the process as many times as they want. The sphere's volumes are randomly generated. They're always different. Oh, and one can choose to res a giant cube as well. The math for the cube is much simpler than the math for the sphere, so sometimes I just assign the cube. I have flexibility, students have repeatability, and hopefully a little fun. And I never run out of paper towels, that's true. Working in Second Life also encourages collaboration. This is a great thing. So this picture illustrates a time when 3 of my students at different places on campus met in Second Life to work on some homework. I have sensors that email me when anyone comes into my science center. So I just dropped by to see if I could help, and all of this was about 9 p.m. Well, how fun is that? With our cold, snowy winters in Rochester, New York, It's sometimes very nice for the students to not have to get together in real life. They can stay all tucked up nice and toasty warm in their apartments. And of course, since all of our students are deaf, the text chat and the ability to archive that chat is immensely valuable. I have a few slides of the various activities that we use in the Science Center, and I'll go through them. Let me check my time here. Okay, I'll go through them fairly quickly, I guess. But if you have a question, please speak up or type them into chat. If you want to wait till the end of the talk, I would really love to hear your questions. I'd love to hear your comments, everything. So we can wait to the end too, because I'll have some time. Also, if you'd like a copy of these slides, this talk, or a PDF guide to the Science Center, please visit. Okay, I just put those in so they'd be in the record. Don't bother to copy them down. You'll see them again later. Okay, here we go. Vector components. Are any of you math teachers? I guess I can't say hands up, but anyway, vector components is something my students struggle with. This activity is not an assignment, not this one. This is for practice. You allow the vector to rotate. It's the blue arrow there, pegged in the middle. Stop it anywhere you like. Record the angular position and the magnitude and calculate the components. In the meantime, the vector will tell you the magnitudes of the components and allow you to see them as well. Are you raising your hand because you're a math teacher? Or do you have a question? Okay, vector addition. By the way, for all of these slides, I've tried to capture what the equipment is saying down there in the lower left corner. So if you want to zoom in, you can probably see them better. When will we get some Linden scripting language functions with Inertia to compute correctly our torques? Oh, yes. When I did that, oh my, when I started working with torques, all of that data that the students get is generated by my script. It has nothing to do with the actual motion of the object, and just for that reason. But it looks cool. And what proportion of your interactive demonstrations survive as originally designed versus those? Oh, I'm revising all the time. I revise constantly. Nothing is safe. I rewrite homework assignments constantly too, sometimes between the time that I give them to the students and the time they're due. It gives Havoc 4, and Second Life Physics is not real life physics. No, 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 it is not. That was a huge, excuse me, my dog is pawing me. That was a huge disappointment to me when I started in Second Life, but I found ways around it. Okay, once they can calculate the components, they go on to finding the sum of 3 vectors. They let the vectors rotate, they stop them at any point, record the magnitudes and angular positions of the vectors, and calculate the sum. And Day, no, I haven't tried using that engine. I'm not even sure what it is. Okay, yes, and you can get pretty close to real physics in Second Life. Let me see. Where am I? Okay. Calculating volume is a challenge for some students. They're all familiar with the concept. They've been doing it since elementary school, but that doesn't mean they know anything about it. So this activity allows them to randomly change the dimensions of 6 geometric shapes and to calculate their volumes. I threw mass in there too, so I can ask them to calculate density if I want to. Right there, I'm standing in front of a large flat disk, which had been quite a small cylinder at the beginning. Area. This is the same concept as the volume calculations, but this time it's the area of 4 regular shapes. It's not very exciting, but it's necessary for some of my students. Okay, this is where the fun stuff starts. Archimedes principle and buoyant force. Now, this activity follows a real-world lab in which students submerge small aluminum cylinders in several different liquids to see what the effect on the cylinder's apparent weight is. Well, here they lower a large copper sphere into 3 unknown liquids, and they use the buoyant force to calculate the specific gravity of the liquids. The homework that I give them is very detailed in terms of steps, the order of what they do, so I don't just turn them loose. Okay, you can res any of 5 objects here. They're a different material. I've got copper, zinc, cork, wood, and glass. You can drop them into a tank of water and see what happens. Again, this is analogous to a lab they do in their classroom. But the water talks. It tells them how much it's come up. Volume, displacement, and buoyancy. This is kind of a cool one. I often reserve this one for exams. This is an activity in which the students use volume, displacement, and buoyant force to calculate the densities of 2 liquids and 2 spheres. There's a lot of, I think it's deductive reasoning. I had to look up deductive and inductive, and I'm pretty sure this is deductive. But it's good for them. It really makes them think. Rotation of rigid bodies, moment of inertia and torque, just what it says. How do I do volume displacement to students? You animate them, or is it just, I'm not sure what you mean. Can you explain your question? Do you mean in the lab with my students, or do you mean in Second Life? Note. Okay, I'll answer that later. Oh, okay. I'll answer that later if you can clarify a little bit to me. Now, students can set any of 3 rigid objects rotating about a central axis. They gather data on the object's angular velocity, answer lots of questions about acceleration, moment of inertia, and torque. Now, this is a favorite for group work. I usually find whole bunches of students gathered in front of this. Uniform circular motion. If you've ever taken physics, you have no doubt answered questions involving bugs on rotating turntables. Well, I could do no differently. Here we've got 4 rotating turntables with bugs on them. Free fall. Each of these 4 towers, I'm sorry, this picture isn't very clear, but each of these 4 towers has a different gravitational field. You can drop spheres, gather information about their speeds, the time to transit between 2 rings, and calculate the acceleration of gravity in each one. Now we're back to buoyancy. Why do some things float? One of the labs that's the most fun to do in real life is to drop various objects into 3 different liquids. It's messy and it's just fun. Students keep a record of which objects float and which sink in which liquids, because of course if you're using alcohol for one and corn syrup for another, it's going to have different results. They use the densities of the objects, and they use the densities of the objects in the liquids to come to a general rule that will permit them to accurately predict whether a particular object will sink or float. And thank you, Note, that's very sweet. They get to test their hypothesis here. The big orange ball announces its mass and volume, and students make their predictions. Whoops. Uh-oh. Sky, what happened to my slides? Well, they test them. Some of those big orange spheres sink, other ones float. Their volumes and masses are randomly determined. And this one floated. You would be able to see that. Okay. Okay, is 32 there? No, I actually blame myself because I have changed these slides about 4 times just today. I kept sending them to iSky, and she kept loading them in and then having to reload them later. Okay. Well, we don't want dead air. I've already been warned about that. So let me see. What else do we do? Oh, we do a lot of things. A lot of my students have aspirations to be engineers of some kind, architectural, mechanical. Architectural, mechanical. I'm sorry. I'm trying to read. I'm trying to read chat while I'm talking to you. And yes, always blame the computer. And frictionless physics doesn't happen yet, but I hope it does. I mean, you can fake that. And actually, I have an activity that's under development right now that is objects sliding down a ramp, and students have to figure out the coefficient of friction between them. Yes, my lab is open for any number of visitors. I mean, you can just come in. If you bring in huge numbers of people, I would like to know about that because the sim is very laggy. It's on the mainland, and we get more than about 10 people in there, and it starts to complain. Okay, where were we? Oh, yes. I was talking about students aspiring to be engineers. They complain about physics. Oh, I can't wait till I'm finished with physics. And I tell them, you guys, engineering is all physics all the time. So a lot of these activities are good for them because it gives them a chance to try different things, which you can't necessarily do in the real lab. I can do really big things in Second Life. Okay. Okay, let me see. iSky says I should keep going. So, density comparison. Density is a derived concept that involves thinking about mass and volume simultaneously. And my students frequently come to class with the unexamined assumption that larger objects are more massive and have more density than smaller objects. Well, if they think about this for a minute, they realize that they're wrong. But it's still a knee-jerk response to physical situations. So in this activity, they generate a sphere and a cube side by side. The sphere and the cube each tell them what their dimensions are and what their mass is, and they calculate the density. And then they keep a table of densities and which object is larger, the sphere or the cube. And they do this over and over and over again. Sometimes the sphere is larger, sometimes the cube is larger. Sometimes the sphere is more dense, sometimes the cube is more dense. But these things are not connected to each other. Oops. So there's no relationship between comparative volumes, shapes, or densities. But after they do this lab, they have to explain and they have to use their data to tell me why this is true. Statics and Newton's second law. Ooh, okay, here we're talking about the civil engineers. They do a lab that involves hanging a mass from strings, and the strings are set at different angles. They measure the angles, and then they calculate the forces in the strings. Well, this is the same thing, but the chains themselves announce their positions. It takes a lot of guesswork out of it, and I wish you could see this. It's much larger than the little tabletop setup that they have to work with. Okay, we started this discussion with the sage on the stage. I have, using virtual worlds, tried to come down off that stage. I have tried to take what my students know in their real lives and create a place where investigation is engaging, always available, shareable, and replicable. Real-life labs are important, but the follow-up is important too. Lab reports are important, but recreating the experience and then answering more questions, both quantitative and qualitative, do more to make the new knowledge a part of the learner than a report that is written and forgotten. Note this: the slides are not being changed anymore. Don't worry about it. I think we lost some in the transfer. This work is a source of inspiration and renewal for me, too. The benefits accrue to me as well. I've learned new skills. I learned to build and I learned to script. I didn't know any of this stuff when I just wandered into Second Life the first time, but creating my own equipment and making it work, it's just been wonderful. And I have discovered community in the generosity and the collegiality of the people in many parts of Second Life and other grids too. I found an outlet for a kind of creativity that I never knew I had until I started to build. After 35 years, this is a really good thing. It makes me want to get into the classroom every single day. And I can't wait for 3D holographic projection systems. Just see what we're going to do with that. There's more. I don't want to wear you out. Feel free to drop by the Science Center and play with the toys. The PDF guide that you can download from my website also contains sample homework problems that go with each activity. Oop. So thank you so much for your attention. I think that what we all do in virtual worlds is often undervalued by people who haven't experienced the possibilities. So I appreciate the opportunity to share with a community that knows and respects the promise of this work that we do. So thank you. I will take questions. Would you like me to put that URL into chat too, just to make sure you get it? That looks right. Thank you, Steed. Any more questions? Day, thank you. That's a nice compliment. It took me a while to figure out exactly how I was going to do that. I mean, were they going to be standalone labs? And I finally decided that what I needed to do was bridge the students' labs and their understanding of their homework. And Second Life just seemed to be a perfect way to do that, because I can bring their homework assignments right into Second Life. They do those on the computer too, so they open two windows. My students are college students. They are mostly 19 to 28, somewhere in there. And then, of course, I have a great deal, many older students who are coming back to work. How do I ensure that students actually engage? Well, first of all, they have to turn in their homework that involves data from those labs. I also have sensors. I keep a record of who comes in and who doesn't. So I did have a student that was making up data one time, and I knew he was because it didn't fall into the range that my data did, and he wasn't on the sensor, so I had to slap him around a little bit. But mostly, they do what they're expected to do, and they like to work in groups, and it works out perfectly. Okay, let me see. I missed the opening part of your speech, so just send me to the notes if you have addressed this. Do you ever run into issues teaching physics in a virtual world where real-life physics doesn't always apply or are simulated poorly? Yes, but not actually. For the kind of physics that I do, for the kind of physics that I teach, Second Life is pretty adequate in most cases. If it's not adequate, I just write out the equations that I need and I script the objects to do what I want them to do. So it works out pretty well most of the time. Anybody else? Any other questions? Okay. Well, oh my goodness, we are really over time, aren't we? I didn't even realize I was having so much fun talking to you. But thank you very much for your attention and your questions. I appreciate it.
Thank you all very much for coming. Professor Robinson has done an excellent job with her presentation, and I hope that you can join us the rest of the afternoon for a few more sessions. And of course, we also have our evening party at the end. Thank you, Professor Robinson. That was excellent. Thank you all very much.
It was a lot of fun, Letty. Thank you.
I'm glad you said that. Thank you all.
No, Carl, they don't.